Okay. Yes, of course, every single time. Okay, one last reminder now that I'm recording. The previous week, we're finishing off the majority of chapter 3 because we have a lot of evaluations coming, okay? And we have no choice. I will try to do my best to make 4.12 a bit more manageable. If you recognize trig ratios and special angles, it all is still based on SOHCAHTOA as well as its reciprocal ratios. So I'll try to allude to your grade 11 knowledge to make it more digestible. All right. So let's do this. How many people got a chance to try my homework task? That is, how many people tried the first examples? First example, rather. Couple people. All right. Let me see if I could rotate this. Is there a way to rotate? No. It looks like this. The graph looks like this. And I think it makes sense for me to do it with you anyways, because if you were diligent with your homework, you will see that, you know what, let me open this with, will this let me open? Nope. Yeah, I might have to. But it still opens up with, oh. Okay, nice, thank you. All right, everyone. If you have been diligent with the homework and you have been trying the DIAEC, I'm going to change it up and just admit I sort of lied to you. The end behavior is actually embedded in your asymptote calculation. Up until now, sorry, Yusuf, I know it was so hard for me to keep my mouth shut, but this is essentially what it is. Horizontal asymptotes is not just checking when it doesn't equal a 0. Horizontal asymptotes is essentially checking what happens when you approach infinity or approach negative infinity. That's what horizontal asymptote is. So I'm going to change the definition on you. I'll let you write something down, and we're going to try this silly question together. All right. So let me quickly do attendance. Melody, welcome. And I realized I should probably not show this on. All right. Yeah, it wouldn't be nice for me to show all your names and information on YouTube, right? That would be a little rough. Okay. So the question is x minus 2, 2x plus 3. I don't need all of this space. I'm actually just gonna use a whiteboard. And here we go. I'm assuming it is recording, right? Okay. Oh, where is my stylus? There it is. Oh, 10. Okay. X minus 2, 2x plus 3. So I introduced very quickly what this essentially means when you have an x value in the numerator. The simplest definition is it's exactly the same as before when you look at the denominator and for asymptotes and whatnot. But the numerator, because there is an x, you can automatically assume the horizontal asymptote will shift. It's going to be shifted up and down. That's essentially what it means. But you don't have to write this down. You can discover it even without memorizing that. Okay, next. As we go through the steps of domain, intercepts, and asymptotes, I'm going to start writing little reminders on the side to tell you what you should be, what you are trying to do to help sketch this graph. So the first part is domain, right? And it's always going to be x belongs to R, but what's my restriction? In this case, x cannot be -3/2. That should be automatic by now. everyone should be like, yeah, that makes sense. Mr. Kim, keep going. I'm bored. Next part, I like to do intercepts because that is pretty straightforward and I don't have to worry too much. Let's do the easiest one. I'm going to do the y-intercept, which means x equals 0. Well, if x equals 0, what is f of 0? 0 minus 2, and then 0 plus 3. There you go. The y-intercept is probably the neatest note taking I've ever done. Wow, so organized. Okay. Wait, that's recorded. I shouldn't be admitting that, should I? Okay, x-intercept. In this particular case, I want to know when f of x equals 0. In other words, I want to know when y equals a 0. Well, if you want to know when y equals 0, what I'm asking you to do is check the numerator. When will f of x, which is equal to x minus 2 over 2x plus 3 equal to 0? When the numerator equals a 0, right? 0 over 10, 0. 0 over a million, still a 0. It all depends on the numerator. And so, therefore, when is x minus 2 equals to 0? When x equals 2. So the x-intercept is 2, 0. Yes. This part. I know that x equals 2 because I am focusing on the numerator. That has to equal a 0. Okay? Of course. Yeah, well, yeah, any number, I want it to equal a 0. I want this entire thing to equal a 0. So I don't care what the denominator is, as long as the numerator is 0. Yes, as long as the top is 0. All right, asymptotes. Here's a little bit of a special note, because as I said, if you do the asymptotes correctly, you already know what the end behavior is, okay? So you can just say asymptote, and you don't have to worry about the E later on. Asymptote. All right, let's do the vertical. Vertical asymptote when is denominator, nay, poor, can't believe this. That's it. Okay, vertical asymptote is when is a denominator a 0? Because when the denominator approaches a 0, that fraction will become super big. Like 1 divided by 0.0000000000001, huge number. It's going to approach infinity. It's an asymptote. Okay. When is denominator equals 0? So in this case, it will be x equals -3/2 is where my vertical asymptote is. Yes. Essentially, yes. You will. I can't think off the top of my head where you would not have a vertical asymptote not agree with the restriction. Horizontal asymptote. Here's a new one. What y value do you approach as x goes to plus or minus infinity? So in other words, horizontal asymptote is actually end behavior. They're actually sort of one and the same. Yesterday, I didn't say that because I wanted you to focus on understanding what horizontal asymptote is. And you didn't have to worry too much because the numerator is always a 1. And then I got you to calculate end behavior separately. From this point on, you can do it one and the same, okay? Even when you go to 3.1, 3.2 and go to the questions again, you can do it this way. You'll still get the same answer. Yes? No, don't worry. You can do either way, right? It's like, why would I penalize you for using more advanced things, instead of like forcing you to use more rudimentary things, right? That's okay. Okay, so this is the vertical, the horizontal asymptote. So you test it. Okay. So here's the funny part. Is everyone ready? You might need some space. So if you don't have space on your sheet, maybe you want to take out a sticker or a piece of paper to copy this down. Yeah. Take a look at what I'm going to do and see how it is going to confuse you. And so we have to do something more. Okay, so this is new. Normally, if we had 1 over 2x plus 3, we stick an infinity there. What do you get? Infinity plus 3. So what's 1 over infinity? Essentially, it's equal to 0. Done. That's my horizontal asymptote. But look what I have here. It's not a 1. I have something else. So, okay, maybe if I do it the same way as I did normal reciprocal functions, I'll get something. So let's do f of x as x approaches positive infinity. That would be infinity minus a 2. And guys, this is going to be wrong. So if you want to watch, that's fine. And 2 times infinity plus a 3. Well, what's an infinity minus a 2? Infinity. What's an infinity plus a 3? Infinity. Oh my goodness. That's essentially undefined. You can't define infinity over infinity. There's no number. So we're stuck. We're going to be doing some number manipulation. And I was speaking to Kinda this morning when she came in and she asked a question. You cannot do it this way. It doesn't give you any good number. So do you remember how I asked you to be okay with 0.001? When we were doing rate of change and we were talking about instantaneous time, we as a class decided 0.001 was a good assumption. Do you remember? In the same way, you're going to have to make a kind of an assumption here. Take a look at what I do. Remember, x is approaching infinity. It's not yet infinity. It's still a number. So if I have x minus 2, then 2x plus 3, I'm going to manipulate it and get rid of the x as much as possible. Take a look. The numerator, I am going to factor an x out. So what is x divided by x? And what is negative 2 divided by x? It's going to be that. Why would you ever do that, Mr. Kim? I know. Bear with me. Can we do it to the bottom as well? Remember, x is not infinity yet. X is still a number, some number. 2x divided by x? Whispers. 2. 3 divided by x would be that. Like, why would you make your life more complicated, Mr. Kim? Because there's always, it's always darkest before dawn. Okay? That makes sense? Bear with me. X is still a number. X is still a number. So if you divide by the same number, what do you get? 1. Thank you. So this becomes 1 minus 2 over x, 2 plus 3 over x. You don't need my face there. Now, x is not yet infinity. It's approaching infinity. So what's the biggest number you can think of? Give me a number. Adam, give me a number. It doesn't matter. A billion. So 1 minus 2 over a billion. What is that essentially equal to? 2 over a billion. What is that? It's essentially a 0. What's 3 over a billion? It's essentially over 0. So what I'm actually doing here, once I apply a number inside the x, I'm essentially subtracting by a 0 and I'm essentially adding a 0. As x approaches infinity, what number is the y going to be? Oops. As x approaches infinity, y will be approaching 1 over 2. Yes. You could. There's a reason why I said a billion instead, because I need to know, is it actually above half or is it below half? Let's put it this way. 2 over a million is basically 0.000002. And 3 over a million is 0.000003. So it's basically 1 over 2. Is it actually bigger than 1 over 2 or smaller than 1 over 2? It's actually smaller. Think about it. Take out your calculators. Okay. 1 minus this is 0.999998 divided by 2.00003. Is that bigger than 0.5 or smaller than 0.5? Try it. It's a little smaller. So when I actually work this out, this is actually approaching half from beneath, from underneath. Question?
I don't know. Like, I couldn't, like, instead of all that, here it's like, if you just take the leading coefficient of the largest variable, put it on the top and the bottom, make an answer.
This is true. However, that doesn't tell you if it's going to be above or below that dotted line. So yes, on the sheet I said, by rule of thumb, if you want to know what the asymptote is, look at this coefficient in front of the x. Look at this coefficient in front of the x. It's 1 over 2. But this part is very important to understand if you want to know whether it's approaching from the bottom or top of it. Is it going to be like this? Or is it going to be like this? You don't know. So you might want to know that there's a little something there, adding or subtracting to each number. It'll help you understand whether it's coming from the bottom or the top. No, not negative or positive, whether it's approaching from the bottom side or if it's coming down from the top side. Well, if you take a look, if I plugged in when x equals 1 million, right? My y value was 0.4999. It's lower than 0.5. It came from underneath. That's how you know. Yeah. So you'll see that in the next one. Yes. How it's approaching. Yeah. Okay. Hold that thought. Once I draw it, maybe you'll see. You're like, okay, I have to watch out for that. Melody? I can't hear you at all. Yes. essentially. It will always be the largest term, so the x's, whatever coefficient is top and bottom, because you are always dividing out or always factoring out an x. Yes, Megan? Exactly. Well, you know it's going to be 1/2. And if you don't want to do this, you don't have to, because once we do the chart, it will tell you. Okay. So yeah, you know what? Saima and everyone else who might be a little confused of this negative portion, it is the first time you're seeing this. So let's take that out for now. And I'll show you another way you can confirm it. Okay. It's fair. Now I have two more things to do. I have to test for negative infinity, and then I have to do the chart. Okay. Ugh, I don't need that. Ugh. Okay. Next, what is f of x as x approaches negative infinity? Well, it's essentially the same thing. I'm going to have x bracket 1 minus 2 over x over x bracket 2 plus 3 over x. And that gets divided out. So I have with me 1 minus 2 over, essentially it's negative infinity, divided by 2 plus 3 over a negative infinity. Or if you want, a billion. So this essentially turns the minus 0.00000 number into a right? It's minus a negative value. Yes, Joseph. Zero plus, yeah, if you want to. If you want to, sure. So essentially what I'm saying is, yes, I'm adding a 0, but you know that it's actually like a 0.00000 something. So if you want to test it, right, for those of you who follow this portion, if you want to test it, see what you get by adding 0.00001 and subtracting 0.001, you will get half from the positive end. It's going to come down from the top. It's going to be, yeah, if this is the horizontal asymptote, it'll be here as I go to negative infinity. As I go to positive infinity, it'll be down here somewhere. Yes.
The sign to write that like the 0 point something is like negative. How do you write that as a 0.3?
No. Essentially, mathematicians, when they see this, when they see 1 plus 2 over the infinity, they put in their heads, oh, this is a little over 1. That's all they think. And this is a little under 1. Right? And they just assume, they figure out that it's going to be above or below a half. Yes. Just to, no reason. I used a million because some people like numbers better than the concept of infinity. So you can do that too if you want. Yes, Rowan?
What if you, without doing all this, if you just plug in the x and y and then ask, what if you are like, if I do it by their hand and know that?
Not necessarily. Unfortunately, not necessarily. There are times where you could cross the horizontal asymptote. So I'm just trying to cover all bases. Okay, the last thing that we need to do is the chart. What are my vertical asymptotes? It is -3/2. Do I have any x-intercepts? Yes, we did. What was my x-intercept? 2. All vertical asymptotes, all x-intercepts go in the row. Yes.
Hold on a second. Where is the
Nope. This 2 is a x-intercept.
oh, so the negative 3 over 2 is
This is the vertical asymptote.
that's your question.
And this part is a 0.
So we, at the top part, we put the x-intercepts and
Yes. Yes. That's why we had to test whether it's above or below 0.5, half. You're absolutely right. So you will see. So thank you for, no, it's perfect. You just went ahead of me. That's all. All right, everyone, take a look. On the left column, you're going to put every single bracket, every single term or binomial or polynomial, whatnot, that has an x in it. So in this case, x minus 2 is one of the terms. 2x plus 3 is one of the terms. And that's it. I don't see a -1 or just, I don't see any coefficients or anything that might cause a change in signs. Let me try to write this more clearly for you. This is 2x plus 3. All right. Which, let's see. Okay, a number less than -1.5, the easiest number I could think of is -2. -2 minus 2 is a negative value. A -2 times 2 plus 3 is still negative. So the entire function to the left of the vertical asymptote is a positive value. A number between -1.5 and 2, easiest number is a 0. 0 minus 2, that's a negative. And then 0 plus 3, that's a positive. So in between the vertical asymptote and my x-intercept, I'm going to be underneath the x-axis. And then I hit a 0, which means I'm going to cross the x-axis. Most likely it's going to be positive now. Number bigger than 2, let's use 3. 3 minus 2, positive. 3 times 2 plus 3, positive. This is going to be a positive. All right. Let me use some thicker asymptotes. -3 over 2. And then I have a 0 at the 2. What else did I get? My domain, my intercepts. What is my y-intercept again? Huh? -2. -2 over 3. And the horizontal asymptote is half.
How does it positive?
Huh?
How is it positive, negative?
Think carefully. If this bracket, so remember the function is 1 over the first bracket, oh sorry, x minus 2 on this bracket and then 2x plus 3 in the other bracket, right? You get it so far? On. So remember, this is basically, this is what f of x is. It's x minus 2 over 2x plus 3. If the numerator is a negative and the denominator is a negative, what's the entire fraction?
No, I understand how to do it, but
I chose a value of x between these two numbers. And when you do so, 0 minus 2 is a negative number. And then 0 plus 3 gives me a positive number.
I know, but if the second.
Uh-huh. You will see. You will see how it changes. No, it means it's above the x-axis. Let me draw it and see if that makes sense to you. So, following this information, if I approach negative infinity, I approach half. Right? Remember, this is half. I approach half. On the positive end or the negative end? Positive end. Right? Remember this? Next. From here, I can't cross this horizontal asymptote. And as I approach this vertical asymptote, I must stay positive. Even if you think it might cross the horizontal asymptote, you know that it can't go in this direction because I don't have a vertical x-intercept here. So it can't be that direction. It has to be like this. Yes. Oh man, I can't hear you. So the purpose of the chart is to see when it's going to be above x-axis or below x-axis. If the purpose is to see when it's going to be a positive or a negative, right? If it has an x-intercept, what does it mean for the curve? It means the curve touched it. So it's in your best interest right now because at that point, we might have a sign change because we're crossing that barrier or it's touching that barrier. So that's why here, you have to put in all vertical asymptotes because there's a possibility that it will sort of teleport. And you should also put x-intercepts here, there, because it's true. If you just they'll break through. Not the x-axis. Yes.
So when you're saying it's like positive, the third one, positive. That when you're saying it's positive, you mean above the x-axis and not above the horizontal axis.
Yes.
So it could be under the horizontal axis.
Yes. As you will see. So take a look. After this curve, the chart tells me that I have to be in the negative side of the x-axis. So I'm coming back here. But from there, I have to go through the y-intercept, and it has an x-intercept. The chart also tells me I have to remain a negative up to this point. It has to be a negative because the chart tells me that. So I will do that. And finally, when it breaks through the x-intercept, I am in the positive zone. And I know I have to go towards half. Am I underneath the asymptote or am I above the asymptote? Doing this calculation, remember that this was supposed to be a negative, so there. And if you want to check, because you're not quite sure, why not plug in 100? Why not plug in 1,000, right? Test it to make sure that you're getting it right. What is f of 100? Well, that will be 100 minus 2 over 2 times 100. 200 plus 3. That's 98 over 203. Tell me what that is. .48275. underneath half. So I know it's supposed to be underneath. So if this is confusing you, once you get to this point, you can always try to test a number that works. Okay. Whew. Long. Single question took about like 40 minutes. That's fine. Next time we do it, maybe it'll take 30 and then 20 and then so on and so forth. Yes. So if there is a different degree. Mhm. Did I give you an example like that in my sheets? I shouldn't. No? I guess not. If not, you get it at the end of class. Okay, it's a good question. Okay, so 3.3, we basically did the first example together. In the back, the second example is actually very simple. So here's what I propose. Let's not get to example 2 because it's slightly different. It's about holes. I want to ask you to turn to the back of the paper I gave you and see if you can do practice question number 2 on your own. Please do practice question number 2 on your own. I'm going to pick it up and we'll go for a walk. No, at the back, practice question number 2, not example 2, not example 2. No, save that. We're going to use that for the example. Try practice question number 2 at the very end of this sheet. And then I will pause this and we'll take it up together. So what we're going to do now for people who are joining us by video. So on our 3.3 sheet, go to the very back. Practice question number 2 is yep.
If we have different ways.
Okay, so as I said, I'm gonna see how long it'll take for me to do it. It'll give you a sense of how much time it might take for you. Here we go. Ready? Let's say it just says, please sketch. If it was a question like this. So first off, I'm gonna start off with the domain. When is this going to equal a 0? -4x equals 1, x equals 1 over -4. Therefore, the domain is xer, but x cannot equal to -1 over 4. Moving on. Intercepts. I'm going to do the easy one first, the y-intercept. That means the x value is a 0, which gives me 0 plus 5, 0 minus 1. Oh, that's a nice number. Okay, so the y-intercept is 0, -5. X-intercept, however, you have to think a little bit more. It's when is the y value equal to 0? It is when x plus 5 equals a 0. So x equals -5. Therefore, I have, well, isn't that interesting? I actually don't know what this looks like, so that's pretty cool. 0, -5 is the y-intercept. X, -5, 0 is the x-intercept. 1 minute has passed. Asymptotes. The vertical asymptotes, my new definition was, take a look at the domain. What's the restriction? When the denominator approaches a 0, we will get a vertical asymptote. So x equals -1 over 4 is my vertical asymptote. For horizontal, what is y approaching as x approaches positive or negative infinity? So what is f of x as I approach a positive infinity? Well, it would be, let's divide out. That's 1 plus 5 over x. X negative 4 minus 1 over x. Simplified. 1 plus 5 over x, which is going to be essentially a 0. Negative 4 minus 1 over x, which is essentially going to be a 0. I am going to approach negative 1 over 4. And it seems a lot of people are trying to wrap their heads around what is it going to be from the positive side? Is it going to be from the negative side? Let's leave that alone for now. Maybe we can just test it at the very end if we absolutely need to. Okay. Moving on. For f of x, what is it equal to as x approaches a negative infinity? Well, it's the same thing, isn't it? So equals 1 plus 5 over, so a negative infinity over negative 4 minus 1 over negative infinity. That's going to be 1 plus, sorry, it's the same thing as 1 minus 5 over a big number. So I'm just going to do it to show you that the signs change. And this is negative 4 plus 1 over a big number. So it still approaches negative 1 over 4, but is it approaching from the positive side or negative side? Again, instead of analyzing it here, how about I draw it and just test the number, okay, to make your life a little bit easier. From there, I also want to do the chart to see which parts of this graph is going to be positive or negative. So excuse me while I get rid of this. This equation has, let's see, my vertical asymptote is negative 1 over 4. My x-intercept is negative 5. So some stuff is happening there. Bless you. I have x plus 5. This has another one. Am I forgetting anything? Doesn't look like it. All right. A number less than negative 5. So I'll stick a negative 6. That becomes a negative bracket. This becomes a positive bracket. So that's negative. A number between negative 5 and negative quarter, I'll use negative 1. Negative 1 plus 5 is positive. Negative 1 times negative 4 is a positive 4 minus 1, that's a positive. It's going to be positive. And then bigger than negative 1 over 4, that's a 0. 0 plus 5 is plus. 0 minus 1, that's a negative. I'm going to get negative. Moment of truth. Okay, I'll use red. X-intercept, negative 5. Y-intercept, negative 5. Asymptote. Horizontal asymptote. Just double check. Yeah. So checking with you, is it sort of along what you have done so far? No? Oh, geez, you scared me. Because I'm legit like I'm just doing this blind, right? I don't have the answers with me. Okay, from there, my chart tells me that I am from this side, negative 1 over 4. I'm approaching from negative 1 over 4, and I have to stay in the negative side until I hit a negative 5. The vertical asymptote, I have to be on the positive side like this. And from the vertical side, I have to come from here and I have to cross this Y-intercept. And I'm assuming I'm doing something with the end behavior. And I have to cross this X-intercept. So this is as far as I've gotten. And it would be nice if I actually touched it like that or touched it like that, but I don't know if I'm going to be above or below. So let's test it. Can you plug in somebody a negative 1,000 here? Someone please plug in a positive 1,000 and let's see if it's above negative 0.25 or below negative 0.25. Can you do that for me? Zach, can you do negative?
Clarify from the negative, putting the negative, how much negative?
This part?
Yeah.
Is it?
When you said plug in negative 1,000, it's coming from.
Yeah, I'm testing when X is negative 1,000. So if I go really far left, am I gonna still be above this dotted line or am I gonna be below this dotted line? Yep.
So we can use one.
You could, again, I would rather you analyze it from here so you don't have to plug in a number, but some people might be a little shaky with that. So there are other alternatives. Okay, so what is that negative 1,000? Anyone? You want me to do it? Oh, time is running out. Let's see. So negative 1,000 plus 5. This is divided by negative 4 times negative 1,000 minus 1. Negative 0.24. In other words, it's not 2.5. I am above. Yes. No, that's what everyone's asking. That's why we have to check. There's a reason. There are situations where it can do something like this. Could happen. It crosses locally, and then it tapers off into the asymptote. So the second one, I'm going to plug in X equals 1,000. So 1,000 plus 5, that is divided by negative 4,000 minus 1. Negative 0.251. So it's lower than negative 0.25. Here's my curve. And that was 10 minutes with the explanations.
It says 13 minutes.
Good try.
Okay. The timer is a bit off. I don't know.
Okay. So this was 10 minutes. This was 10 minutes with explanation. So without explanation, if I'm focusing, maybe I could do it in like 6-7 minutes, or maybe even 5 minutes, maybe even 4 minutes. Either way, that is your goal. I would like all of you to aspire to be so automatic with these calculations that you don't even have to think much. All your brain power is spent on making sure that your calculations are correct, not what do I do next. Okay, all your brain power should be solely focused on making sure you don't make careless mistakes, not what do I have to do. Okay, we're gonna take a break here, go for a walk, and when we come back, we'll finish this lesson. Hopefully we'll start a little bit of 3.6.